Historic radio telescope in the Netherlands, the Dwingelo, toured a quiet patch of sky and intercepted an incredibly faint radio signal. Catching this transmission is notoriously difficult. The signal broadcasts at 8.4 gigahertz, a high frequency that requires pinpoint precision, making it an unforgiving target for older metal mesh satellite dishes. For decades, intercepting this specific frequency has strictly been the domain of NASA's Deep Space Network, a global array of massive, highly sensitive antennas built exactly for this purpose. But the amateur team managed to find it anyway, and the origin of that faint whisper is Voyager 1, a spacecraft currently drifting 25 billion kilometers away from Earth. To put that distance in perspective, the spacecraft has traveled far beyond the outer orbits of Neptune and Pluto. It has completely exited the protective magnetic bubble generated by our Sun. What makes this interception remarkable is the age of the messenger. A machine launched nearly half a century ago is still holding a conversation with us from the dead silence of interstellar space. When Voyager 1 launched in 1977, computing technology looked very different. The most distant object ever made by humans relies on an onboard brain designed in an era when computers still filled entire rooms. Its memory capacity is measured in mere kilobytes. The total memory storage on the entire spacecraft is actually smaller than the data required to send a single digital photo on WhatsApp today. This chart shows exactly how vast that gap is. A standard modern smartphone holds roughly 200,000 times more memory than Voyager 1. Its processing speed is similarly constrained. It operates with less raw computational ability than an early digital watch from the 1970s. Yet this lack of complexity is exactly why it survives. Engineers chose these simple, rugged systems because they would stand massive doses of cosmic radiation and temperature swings that would instantly destroy a modern microchip. Out in interstellar space, the environment is relentlessly hostile. Freezing temperatures and high-energy cosmic rays constantly bombard the metallic hull of the spacecraft. This power schematic shows the physical toll of this environment. Voyager's 3 nuclear-powered generators are steadily dropping in energy output. To counteract this slow decay, engineers are forced into active triage, systematically turning off onboard scientific instruments one by one to conserve fading power. The goal is strict preservation. They are maintaining the bare minimum power required to keep that essential 8.4 gigahertz engineering carrier signal active. Voyager 1 has shed its role as a fully functioning science vessel. It is stripped down to its absolute essentials, doing everything it can to stay alive and maintain contact. The ultra-faint signal the Dwingelo telescope intercepted is no longer transmitting complex data or images. It serves purely as a digital heartbeat, confirming the machine is still awake. Physics, however, sets a hard limit. As the internal power supply inevitably drops further, even this basic engineering signal will fail, forcing the final instruments to shut down. At the moment of total power loss, the spacecraft will undergo its final transformation. It will cease to be an active probe and permanently become a silent time capsule. It will never return to Earth. It will simply continue on its current trajectory, carrying the story of humanity into the cosmic unknown forever. Even after the radio goes entirely dark, this primitive marvel of 1970s engineering will remain. Built on the computing power of a digital watch, it proves that human ambition can stretch far past the lifespans of the machines we build.